In this video, we're going to look at how do we analyze a discrete random variable table. So here below, we have a probability distribution for the number of pets owned in households in Hickory. So the probability that the household has no pets would be 41%. The probability that the household has one pet would be 38%. Notice we don't know the probability for two. It's blank. We can figure it out. Probability of 3 pets is 8% and 4%. 4 pets is 10%. So we want to find the probability 2 pets are owned. So we could write that shorthand as probability x is equal to 2, or we can make that even shorter by looking at probability and just call it 2 there. So let's figure out how do we do that. What do we know about probability distributions? Well, we know they all have to add to 100%. So if I take 100%, which is the same thing as 1, and I subtract the probabilities of 0 pets, 1 pet, 3 pets, and 4 pets, then that will tell me the probability of owning 2 pets. So 1 minus 0.41 minus 0.38 minus 0.08 minus 0.02. When I plug that in my calculator, I get 0.11. So I'm going to fill that in as 0.11. So probability 2 pets are owned is going to be 0.11. B is asking us to find the probability that at least 2 pets are owned. So at least means 2 or more. So we need to find the probability of 2 plus the probability of 3 plus the probability of 4. And we're going to stop at 4 because our table starts at 4. We don't have a probability associated with more than 4 pets. So the probability of 2 is 0.11. The probability of 3 is 0.08. And the probability of 4 is 0.02. And if I were to add those together, I'm going to get 0.21. So there's a 21% chance, based on this data, that a household owns at least 2 pets, which means 2 or more. C is asking us to find the probability that more than 3 pets. So more than 3 would be strictly greater than 3. And if I look at greater than 3, the only thing I can include would be 4 here. So that's really asking the probability of 4 pets, which would be 0.02. We've got to be careful with the terminology that's being used here. At least means greater than or equal to. More than would be just greater than. And if we saw less than, then that would be strictly less than. And if we saw at most, then that would be less than or equal to. So those are some key phrases and the symbols that's associated with those. D is asking us to find the probability that 3 or 4 pets are owned. So we want to find the probability that a household owns 3 or that it owns 4. So those are going to be mutually exclusive events. And we're going to add those probabilities together. And I'm going to get 0.10, which is 10%. So we would expect 10% of households in Hickory to own either 3 or 4 pets. And then let's review that expected value idea that we talked about earlier. Expected value is really just the same thing as asking for the mean of a discrete random variable. And the mean is the sum of each x value times its probability. So let's look at an example. We have a life insurance company that's going to sell a $200,000 policy, 1-year term life policy, to an individual in a particular risk group for a premium of $195. We want to find the expected value to the company if a single policy, if a person in this risk group has a 99.97 chance of surviving the 1 year. So we're going to create a probability distribution table. So X and then P of X. And we're thinking about what the company's going to gain or lose. So there is a 99.97% chance that they're not going to have to pay out, right? So they're just going to get the money from whoever's paying the policy, the person paying the policy. So we're going to have to turn this into a decimal. To do that, we're going to move that decimal 2 places to the left. So 0.9997 is my probability, and the probability that they're just going to get that $195 from the buyer is that probability 0.9997. Now, if this person dies during this year, the probability that that's going to happen is going to be 1 minus 0.9997, which is 0.0003. But what are they going to have to pay out? Well, it's a $200,000 policy, but we've got to take off the 195 that was paid. So if I take 200,000 minus, sorry, I'm thinking about this in terms of the company. Let's do that again. They're going to get $195, but the company's going to pay 200,000. So the company is going to lose money in that case. They're going to lose $199,805. So to show that they're losing it, it would be a negative value. So let's find the expected value here. So we need to take each X value and multiply it by its probability. So I'm going to create that column. 195 times the probability 0.9997. I got 194.9415. And negative 199,805 times 0.0003. I got negative 59.9415. So now we're going to add that column up. So if I add these two values, 194.9415 plus negative 59.9415, and that will give me my expected value. So in the long run, they would expect to gain $135 on this particular policy.